Let's take a disk which is rolling, and let's see if it doesn't have to slip. I mean, it shouldn't slip on the surface. Then what are the conditions for linear and angular velocities? As we know that when this disk is rolling forward, it has two motions. One is rotational motion because it rotates with an angular velocity, let's say omega, as shown here. And it also moves forward. Every point on the disk, let's take this point P, rotates and moves forward, and then rotates and moves forward. So there is a rotation and translation both happening, and the translation goes forward with the velocity which is equal to the velocity of the center of mass, which we can say call it as Vc. This is the velocity with which the disk moves forward, so Vc, and the angular velocity is omega. So these are the two velocities that we need to consider. And let's take this point P, which is of interest for us, which is, we can call it P1, which is in contact with the surface on which the disk is rolling. So at this point, if you see, this point is instantaneously at rest. Why is it at rest? Because if it's not at rest and if it's moving backward, okay, as the disk rolls this way, if this point also rotates along with the disk instantaneously, then this is not gripping the surface. It is also it's actually slipping. So at least instantaneously, as written here, it needs to be at rest for an instant, then it again moves. So the point which a fraction, I mean very tiny portion of the disk which is in contact with the surface, the point P1 at any instant, is at rest, which means the forward movement velocity is nullified by the rotation velocity in the other direction due to omega. So the velocity with which it's moving forward, or rather the translational part, is, let's say, Vc for P1. Let's consider this for point P1. And if you see at P1, the rotation is in the opposite direction at this instant to the linear translational movement forward. That we know is r omega, radius times angular velocity, r omega. So Vc is equal to r omega, means that point P1 is instantaneously at rest, which means it's not slipping. So the condition for not slipping is Vc should be equal to r omega, which also means that if you consider a point P2 exactly diametrically opposite to P1 on top of the disk, at that point it has Vc in this direction at P2. Let's take P2, and r omega is also moving forward if you see instantaneously at that point. So r omega plus Vc both add together, which means at P2, at point P2, the velocity is Vc plus r omega. This is the velocity at P2 for any object that is going through a rolling motion. Thank you.